The two pulleys A and B with radii 2.5 and 5.5 centimeters respectively are connected by a rope such that the rotation of one pulley results in the rotation of the other pulley without the rope skidding on the pulleys. As part A of this problem, if the pulley B rotates 15 degrees, how many degrees will the pulley A rotate? Okay, let's consider part A for now, and then we will look at part B. Let's see whether we can establish a relation between the rotation of pulley A and the rotation of pulley B. Let's consider a point on the circumference of B. Let's call it M. This is actually a point on the rope, and its point of contact with the circumference of the pulley B. And let's consider an arbitrary point where the rope is not in contact with the pulley, and call it N. And let's consider another point, let's call it P, on the rope where it is in contact with pulley A. Let's say the pulleys are rotating counterclockwise, and let's say if we wait for a short time, the point M goes to point M prime, point N goes to N prime, and point P goes to P prime. Then, with a bit of thinking, it is clear that the arc M prime has the same length as N prime, which has the same length as the arc P prime. Now, if we ignore N prime, we will have that the arc M prime is equal to the arc P prime. This may not be obvious in itself, this equation. However, if you consider that both of the quantities here are actually equal to N prime, then it is easier to understand that these two quantities, M prime and P prime, are actually equal. However, M prime is related to the angle of rotation of pulley B. Let's connect point M to the center and point M prime to the center. Then theta B would represent the angle of rotation of pulley B. And if we consider the line connecting P and the center and P prime and the center, then theta A would represent the angle of rotation of pulley A. And we know that the arc M prime, erase these, okay, we know that the arc M prime is equal to the radius of pulley B times theta B, and this would equal to arc P prime, which is the radius of pulley A, times theta A, where theta A and theta B are in radian. This equation should be enough for us to be able to relate the angle of rotation of one of the pulleys to the angle of rotation of the other pulley. If we substitute the values we have, we can find the unknown we were looking for. However, to simplify our calculation, let's rewrite this equation in the following way. Theta A over theta B is equal to RB over RA. To verify whether this equation is correct, you can go backwards by cross multiplication. Theta A times RA would be equal to theta B times RB, which is the original equation that we had. Therefore, it is correct to say theta A over theta B is equal to RB over RA. Now let's plug in the values that we have. Theta A divided by theta B, which is 15 degrees, is equal to 5.5 times 2.5. The reason that we are using this equation rather than the original equation is that we would not have to convert the thetas into radian. The given angle is in degrees, and the answer is also asked to be in degrees. When written in this form, theta A over theta B, the unit does not matter anymore because the units will cancel. You could use for both thetas radian or degrees, and the equation would still be correct. Now if we solve the final equation, we will get theta A is equal to 33 degrees. And that is the answer to part A. Now let's look at part B. If the pulley B rotates with an angular speed of 2.3 radian per second, what is the angular velocity of pulley A? So omega B is 2.3 radian per second. Omega B is 2.3 radian per second. Let's look at the equation we found a while ago, and that is this equation. RB theta B is equal to RA theta A. Theta B represents the angle of rotation in a certain time interval of pulley B, and theta A represents the angle of rotation of pulley A in a certain time interval. Let's say that time interval is delta t. Let's divide both sides of this equation by delta t. We would get RB theta B over delta t is equal to RA theta A over delta t. But change in angle divided by change in time is nothing but angular velocity. Therefore we can say RB omega B is equal to RA omega A. Now in this equation, if we plug in the unknowns, the knowns, we can find the unknowns. RB is 5.5 and omega B is 2.3. This would equal RA, which is 2.5, and omega A, which is unknown. If we solve this equation for omega A, we would get omega A is equal to 5.06 radian per second.